Hello.
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 Hello!
Hello.
Hello.
Hello everybody, we are the Supercooling team, and today we will present you our team, our participation, winning and experimentation of the Beamline for School. At first, I propose you to know each other. Let's go!
I'm Louis.
I'm Ulysse.
I'm Alexandre. I am Mathieu.
I'm Clemence.
I'm Brewen.
And I'm Antoine, the team leader. We are both different, with different passions and ambitions, but we are all 17 and we come from the Sacré-Cœur private school at Reims in France.
How did we decide to participate? Well, Antoine heard about the competition on the Seine website, and as we were already friends and classmates, we decided to compete together. Then we asked our physics teacher, Frank Lipinois, to be our coach, as he speaks English very well. At this point, we needed a purpose, so we did brainstorming and we came up with the idea of the supercooling chamber. But what is it?
The supercooling effect is a state where liquids, like water, are cooled down below the temperature of fusion, even if they are still liquid. This state is very unstable, and a simple variation of energy will lead to the entire crystallization, as you can see with this bottle. This effect is very impressive, but you can easily reproduce it at home by putting some regular water in a freezer and then just waiting for about 2 hours and 45 minutes.
The idea was simple but never seen. Use this effect in order to see if beam's particles can release their energy into a tank of supercooled water, crystallizing it on the surface and creating a new kind of detection chamber, the supercooling chamber.
All of us were fascinated by this experiment idea, and so we were ready to write our proposal. We divided the tasks. Some of us did calculus to see if this effect could be possible, because it was a never-seen experiment. Others did researches about the setup needed for the experiment. Still others wrote the proposal, and finally, those who remained did a video. But all of us contributed to each task, bringing real plus.
So, it was not easy to work on such project with the schoolwork and exams in the same time, but we succeeded in sending our proposal 50 minutes only before the end of submissions, which was stressful. Don't do that.
Then we waited and waited and waited until June to see if we had something, and one day we learned that we were qualified after a close selection. We couldn't believe it. Our families were proud of us. We could realize our dream.
During the summer vacation, we did a little extra work, but it was not so hard because the majority of all our tasks were already done. We also began to exchange with an incredible person, Paul Malek, who helped us a lot before and during our experiment. He was there to coordinate our journey and the experiment, and he did it very well. We learned a lot of things thanks to him. After a wait of 2 months, it was the D-Day, we took a train to Hamburg.
All of us were excited. After a long trip, we have met Paul and visited Daisy. This place is the dream for every scientist. And we also have discovered unexpected and wonderful technologies. For example, we saw a real cloud chamber, which is a particle detector using an unstable state of gases to create particle trails. And this is this device which inspired us for our supercooling chamber. So it was quite impressive to see it for the first time.
However, doing this project will allow you to leave something anecdotal compared to carrying out your own experiment on a particle accelerator, but which is nevertheless interesting. Indeed, you will be able to visit the city where you go. Hamburg, with its port or its city center, or Geneva, with its city center or its cathedral. It is absolutely worth the detour because it's important to discover places mixing science and culture.
The teamwork was a big part of this journey. In fact, we had to use the beamline as much as possible to have results in such few tries. We had to make 3 groups during the experimentations to use the test beam as much as possible during the 2 weeks we had in Hamburg. The work of the other were to analyze the data produced by the detectors on the experimentation place. The disagreements and the compromise were part of the experience in DAISY. During this stay, we learned a lot about science in general, but also about others and teamwork, which was very nice. Quickly, we launched tests. We did a rotation. When a group was on the test beam to experiment, the others were in another room to analyze and process data.
Discovering DAISY was an incredible experience. They have a lot of instruments and a high quality staff. All the persons were specialized in a very specific field, and they succeeded in transmitting their knowledge even in a short amount of time. The most amazing part was to discover the test beam area. We were all amazed by this very symbolic place.
We can describe our setup like this. We have the tank of water here at the center, which is covered by insulating foam to keep the water cold. Below the chamber, we put Peltier elements, which cool down very quickly the tank. Here we also put a thermistor to take the temperature of the tank. Above it, a camera was put to record water crystallizations. Also, Paul decided to set 6 telescopes to analyze the beam composition and the number of particles going through the chamber. A huge red electromagnet was also here to focus the beam. All the experiment was controlled at distance by computer in a control room. Here we could control the beam and the particles' momentum. We started to save temperatures, draw graphics temperatures, and record videos. All important information was compiled into a notebook.
After a moment, we observed our first crystallization with the beam off, as you can see on this video. This was due to an asperity on the thermistor, so we decided to remove it.
However, after we started to turn on the beam, nothing special happened. Every crystallization seemed to be due to an external cause and came from one of the edges of the tank. So we tried again and again to solve the problem, and finally, after days of experimenting, we finally got some interesting results. As you can see here, the crystallization is very different from the other one, for the main reason that the crystallization doesn't come from an edge of the tank, but directly started in the center, and that is why this is a crystallization which is very interesting for us. We think that the crystallization is due to an electron which forced the water crystallization, and that its interaction has modified the pattern of water molecule disposition.
We were so happy. It was a proof that we were on a good way. But unfortunately, we didn't succeed to obtain these results again before the end of our journey.
We took many data from the telescopes, at first without any tank, then we did it with an empty tank, with one full of regular water, and finally with some supercooling water in it, in order to compare them. But we have faced some issues. For instance, in our data, numerous events were either empty or filled with many clusters, so it was difficult to select the useful ones. We have worked on data for weeks because it's not easy since we didn't have any experience on this area of research. So if you win Beamline for Souls competition, try to have a minimum of knowledge on data analysis, even if it's not mandatory at all.
All these data will help us to write a paper on our experimentation, and we also plan to repeat it on other particles accelerator in order to confirm our hypothesis and establish a model of the supercooling chamber.
What did we learn? Taking part in this competition is an incredible way to acquire new skills and to learn lots of new things. First, we learn how to work as a team. That's to say, how to pay attention to what each member of the group wants to do during the preparing of the proposal and also during our stay at Hamburg. We also discover lots of physical aspects linked to particle physics we have never heard about before. Moreover, during our stay at DESY, we were able to discover the reality of scientists' work because we kind of lived during a week like real scientists. We discovered also how the beam works and how to control it, how to collect data, and how to analyze them in order to present them after. To conclude, we can just be really thankful to the organizers of the competition because we have learned really lots of things.
Winning this competition doesn't only mean having the opportunity to realize your experience. Indeed, we have become ambassadors of the competition, and we want to encourage young people like us to participate at this contest. And to do this, we have organized conferences, and more generally, we have published our success, notably by appearing in newspaper or on the radio. We sincerely hope that more and more students with a passion for physics and an appetite for adventure will take note of these competitions, which allows us to immerse ourselves in the exciting world of research. Finally, to conclude this short video, we would like to thank all the persons who made this adventure possible. So we would like to thank Margarita, Marcus, Paul, and all the organizers of the competition for being so caring, attentive, and committed. Also, all the sponsors, without them nothing would have been possible. And last but not least, the research laboratories of CERN and DESY who accept to share their facilities with students like us without any real experience in particle science.
Beamline for School is a chance for everyone. We did it, so you can too. You can do it. Just don't hesitate. Focus on an idea and just write a proposal now. It's your turn. You can do it. If you want to ask some questions, we put an email right here, and maybe see you soon. Just don't hesitate.